ladies and gentlemen. Welcome to STEMAIDE Insight Series, your day 3 online 3D workshop. In fact, today marks our last day for this 3D online workshop, and I'm so amazed going through this happy journey with you. Ladies and gentlemen, welcome once again to STEMAIDE Insight Series. At STEMAIDE, we say reinventing the future. In fact, to those who do not know what STEMAIDE is an edtech company that is on the mission of providing quality STEM learning materials to every African on the continent. At STEMAIDE, once again, we say reinventing the future. A future where you and I can have practical science, technology, engineering, mathematics at anywhere we find ourselves. Yes, today marks the day 3 and the last day of our 3-day online workshop. And I'm so glad going through this journey with you. In fact, once again, my name is Lapi Moriti Joseph. I'm a technology and a fintech educator specializing in the field of robotics, STEM education, and financial technology. All I do is to equip you with the future of the fields I've just mentioned. In fact, today, family, is going to be so amazing because we've got a whole lot of bunchy projects today to do. In fact, ranging from the first day, what we did, second day, what we did. Today, we are topping up and then combining all together to build a solid system. Yes, I know you can't wait to see this system. So, ladies and gentlemen, if you don't have the resources and the materials to join us, to follow us along, I will urge you to move on onto the description below this stream and then get your link to your Google Drive, our Google Drive where we've actually saved all the codes, all the things you need to literally move on with us. Once again, family, let's jump in. Yes, so today we are going to be talking about the smart security gate system. Yes, this is a system we've intentionally built. And what it does is that it's coming to make the work of most security men much easier. In fact, this is not coming to take their work. It's coming to make it much easier. So how then do you know it's coming to make it much easier? Yes, let's go through this project and then we can know what I mean by it's coming to make the work much easier. So right on my screen, you can see all the tools and then components we are going to be using during this section. We are going to be using the following components to build this wonderful project. And if you don't have the physical one, you go with us on the Tinkercad software. But then, if you need a physical one, I will urge you to move on to get your STEMAIDE Coder Kit. All-in-one kit where you can have everything you need to follow us in this kit. Head on to www.stemaideafrica.com or www.stemaide.com to get more information on the STEMAIDE Coder Kit. Ladies and gentlemen, family, let's jump in. Right away, we are going to be talking about our component we are going to be using to build this simple but, let me say, crazy circuit. So this is our Arduino Uno board, which is our component 1. That is a microcontroller. So today I would like to take my time to break down some of the functions of the components we have been using. I had a whole lot of people coming into my DM saying they want us to break down what the components actually do and then what they are. So one thing about the STEMAIDE Coder Kit is it has 4 categories of components. It has the sensors, it has the motors, it has the LEDs, and then it has the sound component. So these components are in different types. So today I'm going to be talking a little bit about them. So we have the microcontroller, which is the Arduino Uno board. This board is like a small computer. What it does is that in fact, whatever a computer does, but just like this one does not have something like a interface or something that way. Probably we upload code on it and then we run our code. So anytime I upload a code on it, it has an IC, or let me say a memory, that stores the code. And at any time I want to use my code, I just have to give it power and then literally it runs my code for me. So being all instruction that I'm giving, it runs my code for me. So this is called the Arduino Uno, which is the microcontroller. Aside that, we also have what we call the ultrasonic sensor, being our component 3. This is a sensor that literally helps us to measure distance and then also sense objects right away about some distance above it. So for instance, this sensor has two main parts, being the transmitting transducer, which is the one eye you see over there, and then the other eye you see is the receiving transducer. What this does is the transmitting transducer transmits waves, and then the receiving transducer receives the waves whenever the waves bounce back. So this is something so simple, and this is a sensor that we use in so many applications. We can use to measure distance, we can use to do obstacle avoidance. Aside that, we can also use it to do a whole lot of stuff. And then right away, we have our component 2, which is the buzzer. So we have the buzzer, and then this a small component that produces sound. So yesterday, I was saying these components, we can program it in such a way that it even sings happy birthday for us. This is kind of like a mini speaker, but then it only produces tones. Yes, aside that, we also have the push button. The push button, yesterday, if you were part of our section, you get to know what a push button is. Ladies and gentlemen, if you have not been able to follow some of our sections, I will urge you to literally after this session, go back and then re-watch our previous sections so that you can get more understanding of what I'm talking about. Then we have the servo motor. So I call it the little motor. So I have my servo motor here. So this is a motor that rotates on a 180 left and a 180 right. So probably 360, but then it only goes on the 180 left and a 180 right. So we are going to be using this motor as our moving object to literally close and open our gate. Then we also got the LED, which is the RGB. I call it the RGB, and then the reason why we call it the RGB is that it stands for red, blue, and then green, signifying that it is a 3-in-1 LED. So it has three LEDs in it, which means 3 colors. So this is like a single bulb that produces different colors. So we call it the RGB. R stands for red, G stands for green, and then B stands for blue. Then we also got our resistor, and then we got our jumper wires. So these are the components we are going to be building with. And then don't forget, we got our breadboard at the back. That is what we used in making our connections. So ladies and gentlemen, before we jump in onto our Tinkercad project to start to build, I will urge you to help me share this to any loved one out there. Also, don't forget to subscribe to this YouTube channel, because from now and time to come, we'll be sharing more of this insightful moment with you. So make sure you help me share this with any loved one you feel this is much great for, especially someone who is zero knowledge about technology. Our mission is to make sure everybody understands technology to the core fundamentals. So we start with basic electronics, get to understand the technologies behind, or the basic technologies or the basic concept behind many technologies. So ladies and gentlemen, I know you are going to do this, and I believe that. So let's jump in to our real-time Tinkercad project. So I'm going to be taking you guys through the Tinkercad project. We are going to be building using our Tinkercad software that we have here, and then we are also going to be testing our project. So already I have got my project built already using the Tinkercad, and then I'm going to run a test for you to have a look at how it is, what it is, and then how it works, so that we can build it right away from the first to the last, and then program it as we want it to work. So, ladies and gentlemen, I'll also be breaking down some of the codes, and then their functions, their logics, and then their meanings to you. So make sure you stay intact. Right away, I'm going to jump in to simulate my project here for us to see how it works and then how to go about it. So I have my project here. I have my ultrasonic sensor. Being this sensor, it's called the HCSRO4 ultrasonic sensor. It has the transmitting transducer, which is represented by the T in the corner here, if you have a deep look. And then we have the R, which is the receiving transducer, which is being represented by the R. So this is the transducer. And then what it does is it shows waves anytime it bounces back, and then the receiving transducer receives it. We have the buzzer, which produces sound whenever an action is being triggered to it. We have the servo motor, which turns 180 left, 180 right. We have the push button here, which also serves as our switch or our instructor to instruct whether the gate should open or not. And then we have our Arduino Uno board here, which stores our code and everything we are running with this system. So this system is a little bit smart in such a way that it could even detect whether there is human or no human. Yes, so we are going to be building this together with you. Now let's jump in. So I'm going to stimulate my work, and I would want to stimulate it. So I'm going to the stimulate button here, and then I'm going to click on the stimulate. Now I have everything here. It's running. I'm going to stimulate it. So after putting on my stimulation, I come back to my ultrasonic sensor. Now, what this simply means is that if you are using the STEMAIDE Coder Kit and then you have the physical ultrasonic sensor, it measures within a specific range. So we program it in such a way that whenever the ultrasonic sensor is sensing someone or sensing an obstacle within a specific range, it should trigger an action to our system. So this is the sensor, and then this is the range. So the range is what you see here. And then anytime we drag our sensing to the range, our LED change color, signifying that there is someone, and therefore the security man has to press on the push button here to open the gate. And then after some time, the gate recloses again. So we are going to be demonstrating this system here. So first, I'm going to make sure my ultrasonic sensor is within the range. So right now, I've kept it in the range. That means that it can sense an obstacle. And therefore, what it got to do is that it is sending a signal to my project here, or my code, or my little computer here, telling it that there is a human right in front of the gate, and therefore it has to trigger an action. So I want you to pay attention to my servo motor and look at my buzzer. I'm going to press on the push button. So whatever happens here is that the security or whoever is in charge of opening the gate would just have to look at the LED, the color based on the color. So specifically when it is blue, that means that there is someone behind the gate, and therefore he or she has to press the button to open the gate. So now I got my button pressed, and then it opened the gate. It waits for some time, then it automatically closes back again. So this is a simple system. So probably I'm going to run a test again. I'm in my range, and then I'm going to be pressing on my push button. And then the moment I press on my push button, you saw my servo motor moving. Then after some time, my servo motor closes back again. Yes, so this is the system I'm going to be building with you. And all I need you to do is to follow me step by step. Now, someone will ask the question, what about if there is no person within the range? So we are going to be measuring no person. So this simply means that there is no person within the range. So our ultrasonic sensor is not sensing within the range. So what I'm going to do here is that I'm going to take out my ultrasonic sensor measuring from the range. Now it is out of the range, and I'm going to press the push button to see what happens, if whether my circuit is actually thinking or not. So I'm going to press on my push button here. I press it, and then it represents red. It comes in red, telling me that there is nobody behind the gate, or the ultrasonic sensor is not sensing anybody. So therefore, it is not necessary for you to open the gate. So I'm going to press it again. We have to keep a look at my my servo motor and then my buzzer to see if whether it's going to open or not. So I click it, and then it has not opened, but my LED turns on red, telling me that there is nobody. So I'm going to put my ultrasonic sensor within the range again to see if whether it would work or not. So I have kept my ultrasonic sensor within the range. I simply press my push button, and then my system opens. So this serves as our security man, and then opens the gate whenever the logic is functioning. So ladies and gentlemen, this is the system we are going to be building today. And it looks a little bit bunchy, but then it's so simple to do. And I'm going to be doing it with you right here. All I request from you is to subscribe to this YouTube channel. Help me share this to your loved ones. Make sure they are able to understand the simple and the basics fundamentals behind technology. Ladies and gentlemen, we go into our building. So I'm going to start with my breadboard, which is this main component you see here. So starting with my breadboard, I'm going to drag my breadboard and then drop it here. So I have my breadboard here, and then I have to look for my Arduino Uno, which is my second most important component, my mini computer that is going to store all my code, and I'm going to be able to run my code from this mini computer. So I'm going to drag and then drop my Arduino board here. So I have enough space to have a look at it. Then I'm going to be mounting my components on my breadboard. So first component is the ultrasonic sensor. That is the HCSRO4 ultrasonic sensor. So I'm going to be mounting my ultrasonic sensor on my breadboard. All I have to do is to come here. I have my ultrasonic sensor down here. And then I am going to drag and drop my ultrasonic sensor onto my circuit. Then I can zoom out a little bit. I have my ultrasonic sensor here. Click on it, and then I'm going to be mounting it on the breadboard. So I'm going to be mounting it on the breadboard. I have it here. Now, with those using the STEMAIDE coder kit, the ultrasonic sensor has 4 pins with the module that comes in the STEMAIDE coder kit. But then, if you are using the virtual one, it has 3 pins. But if you are using the physical one, which is the HCSRO4 ultrasonic sensor from the coder kit, it has 4 pins. And what this sensor does is it has the trick pin, the echo pin, and then the VCC, which is the power pin, and then it has the ground pin, being the 4 pins. This is the basic pins we are going to be using. So I have my ultrasonic sensor being here. And then my last thing, I don't like this model of the ultrasonic sensor, so I'm going to look for my big model. Don't forget, we are using the HCSRO4 ultrasonic sensor model. And this is not the HCSRO4 ultrasonic sensor model. I change it, and then I'm going to get my HCSRO4 ultrasonic sensor. Kudos. With our HCSRO4, it has 4 pins. So we have the GND, we have the echo pin, we have the trick pin, and then we have the VCC. This simply means, the VCC pin simply means power the cheek pin is for signals for transmitting transducer, and then the echo pin is for receiving signals from the receiving transducer, and then we have the GND for our negative. So simple circuit, I'll mount it on my breadboard. Now I'm going to pick my second component I have here. So if I'm to have a deep look, I have my buzzer. So I'm going to be picking my buzzer component, and then I'm going to be mounting my buzzer right away on this breadboard. So I scroll, and then I keep looking for buzzer. So I keep scrolling, and then I have my buzzer here. So I'm going to drag and then drop my buzzer within this lane. Now, don't forget, the breadboard works in vertical and horizontal connectors, and therefore make sure it is being connected in the right way. And our buzzer also have the terminals being the positive and then the negative terminal. So make sure you're able to identify them and then the kind of hole it is being inserted in. So this simply green lines means that whenever I put a power here, the power flows right away from here to this side, and it does not even cross to the next lane. It only remains within this range, and therefore I don't have to make a connection out of this range when my circuit is not being connected to that range, or my component is not being connected to that range. So I'm going back again to continue building my circuit. Now my third component, or most important component, is my security man here, which is the servo motor. So I'm going to pick my servo motor and then mount my servo motor. So I have my servo motor here, and I drag it, I drop it here. So I have my servo motor being mounted here. Now I want to rotate my servo motor to face wall for easy wiring. So all I have to do is to click on my servo motor, press on the R key for rotation. I press R till I get the kind of rotation I want, and then I can leave it. Now I have my servo motor, just as I can see here. I have my buzzer, I have my ultrasonic sensor, and then I have my Arduino Uno board. Now we continue to build. I'm going for my push button. So I'm going to get a push button and then mount it on the breadboard. Now we have to have a deep look at the push button. It is being mounted within this range and this range. So that means that with the push button, I can make a connection from here to this side and then right away from here to this side. So you should take very good notice of the push button and how it's going to be connected. So I'm going to look in for my push button. Then I keep scrolling till I get my push button. So I have a whole lot of components here, different kind of components, each of them, and then their basic functions. So I'm going in for my push button. Now I have my push button here. All I have to do is to drag and then drop it, actually mount it on my breadboard. So I'm going to be mounting my push button on the breadboard. So I still have to put it well. Now I have my push button mounted on the breadboard. Ladies and gentlemen, we are gradually building the circuit. Make sure you're able to follow us. And if you are finding yourself wanting in a place you don't understand something, feel free to reach out to us on our channel. We have our WhatsApp channel using the link in the description below. So make sure you get our WhatsApp channel and then feel free to reach out to us. Also, feel free to share and then subscribe to this channel. Ladies and gentlemen, we continue to build our circuit. Now I have my push button, I have my ultrasonic sensor, I have my servo motor, I have my Arduino Uno board, and then I have my push button well connected. Now, all I need is to get my resistors and then my RGB module. So I'm going in, I have my RGB module here. This is a simple module, so I'm going to get my RGB module and then mount it on the breadboard. So all I have to do is to look for my RGB module here, and then as you can see, I have my RGB. I'm going to drag it and then drop it on the breadboard. board. Right away, I have my RGB model being mounted on the breadboard, and I don't want it to come in contact with my push button. So probably I have to look at my wiring to determine if whether it has to come. Now with my wiring that I've got at the top here, it is not in contact with my push button. So I'm going to make sure I draw it away from my push button. Ladies and gentlemen, we are almost getting to the close of the mounting of the component. So make sure you are able to get intact. Right away, I have my RGB mounted correctly. Now my last but one component I would have to mount is my resistor. Now this resistor has its resistance, and then I would have to know the resistance. So first I click on my resistor. I will first click on my resistor, and it tells me the amount of resistance. So this is a 220 ohm resistor. So I have my 220 ohm resistor here, and then all I have to do is to mount the same thing on my breadboard. So I'm going to scroll and then get my 220 ohm resistor. Now with the resistor on the Tinkercad, what it does is that you first have to drag it, and then you can later change the resistance capacity. So all I'm going to do is to drag and then drop it, first mount it, and then I can zoom in. I have it here, and then I'm going to put it on one of the legs of the RGB. So just as you can see, I have it connected to one leg, the second leg, and then I can ignore the third leg, then I can do for the fourth pin. So that's the same way I'm going to be doing for here. And then automatically my resistor is in 1K ohms. So I'm going to click on my resistor, scroll a little bit, and then change the resistance. So I'm going to change it to 220 ohm resistance, and then probably not kilo ohms. I want the ohms. I select the ohms, and then I know I have the 220 ohms. So carefully, if you can have a look at it, it's the same colors just as I have it on this side of the circuit. So I'm going to keep mounting my resistors just as I can see it over here. So going to copy this and then paste it, and then make sure it's on the second pin. Then copy it again, paste it, and then I can ignore the third pin and then put it on the fourth pin. Now, ladies and gentlemen, family, we have our components being mounted on the breadboard, and we are ready set for wiring. So let's move on to the wiring aspect, and then we can literally finish building our circuit. Then we can move to our coding, where I'll be breaking a little bit of the code to you. For time's sake, I will not want to elaborate all the code, but then I'll be breaking the most important functions to you so that you can know what we are dealing with. And then you can also make your little tweaks or your little updates you want to do with it. So you can play around it. Yes, so let's continue with our wiring. Carefully, when it comes to electronics, all my first advice is you do one thing at a particular time, and then you do it right away, being focused. Because if you are trying to give more attention to the wires, trying to look at the wires, it's going to be a little bit confusing. So we are going to take the wires one after the other and then connect it to our Arduino Uno board. So I'm going to take my first cable, which is my red cable. I'm working with my HCSRO4 ultrasonic sensor. So I'm going to click on the wire to know where the wire is being connected. So right away with my red wire is being connected to my positive terminal or my positive lane of my breadboard. So that is what I'm going to be doing on this. So first, I would come to my first lane, which is my VCC. Bear in mind and don't forget the kind of pin you are dealing with. So I'm dealing with the VCC pin. I'm going to drag it and then try to connect it to my positive lane of my breadboard. So this is what I've got here. Now, don't forget, my wire is color red over here, but then we have it green here. So all I have to do is to change the color of the wire. So first I'm going to click on the wire and then move down here, change it to red, and then I finally have my red wire. Then, family, we continue to build or to wire our circuit. Now, with our second circuit, I'm going to be looking at my check pin, which is the one connected to the blue. So first, I have to track the blue. I know the blue comes down right away here to the pin number 7. So I'm going to connect my check pin on my building circuit to my pin number 7. Now, we would recommend you not to be mixing the pins for the sake that the code has been written in specific pins and then has been assigned to specific pins. Probably after you get to understand the code, you can make your tweaks and you can change your connection on the Arduino Uno board. But then, for now, we should keep stick to our current connections. So I'm going to move to my check pin and then take a connection. I would like to still curve and then take a little bit curve and then move on to my pin number 7, which is the digital pin 7. Now, bear in mind, our wire is supposed to be blue, just as we can see here. So I'm going to make sure my wire is blue. All I have to do is to click on my cable or my wire here, click on the color menu and then choose my green. Then I have my green connected to pin number 7. Right away, I'm going to continue with my circuit. Sorry, it's supposed to be green. It's supposed to be blue. I made it green. So all I have to do is to still click on it and then drop and then choose my blue. So I'm going to click on my wire and then I'm going to choose color blue. Now, well, people might not call it blue, but I call it blue. So I have my blue connected, and then all I have to do once again is to look out for the next connection. Don't forget, we are taking the connections one after the other to make sure that we don't mix our connections or we don't get ourselves misunderstood. So, ladies and gentlemen, brothers and families, we continue building. So all I have to do is to track my second wire, where it's coming from, and then where it's going. So this is simple way to understand basic electronics, because we need to follow what has been done already to understand what is in the future. So probably all I have to do is to look out for my echo pin, which is my third pin, and then all I'm going to do is to track where the wire is going. So my echo pin, this wire has been connected to the echo pin, which is the receiving transducer pin. And then it's going to my pin number 6, as I can see here. So I'm going to be mounting the same or wiring the same thing on this circuit. So first, I'm going to zoom in onto my echo pin. So I'm going to be zooming in onto my echo pin. I have my echo pin here. All I have to do is to click and then zoom out a little bit, move, and then I would like to take a curve, then negotiate another curve. Then I would like to put it on my pin number 6. But then don't forget, my cable is cable green or wire green. So I'm going to be changing it to green. And then I have it here. Now I have my green here. And then I have all my connections well made. Now I'm going to my last cable or my last pin on the ultrasonic sensor, the HCSRO4 ultrasonic sensor. So I have to look at it, which is the GND. And then I come back to my master circuit and I have a look at my GND, which is going to my negative terminal of the breadboard. So I have the negative lane. So all I'm going to make sure do is to make sure that my cable right away from the GND is going to my negative side of my breadboard. Ladies and gentlemen, make sure you subscribe to this YouTube channel and then make sure you share this to your loved ones, because more and more time to come, we'll be sharing more insightful journeys like this with you on this channel right at this times. So make sure you get your loved one join this exciting and amazing moment. So, ladies and gentlemen, we continue to build our circuit. I have my GND, which is my ground. Probably GND is simply my negative terminal. You know, in every circuit, for light to exist, we have to have the positive and then the negative. So this is my negative terminal. And then I have my VCC, which is my positive. VCC simply stands for voltage collector current, which means it's in transistors, and then it works in transistors. So it's literally our power source here. But if we are to move in deeper and deeper, we will get to understand what it means. So all I have to do is to make sure I am getting my GND connected to my Arduino Uno board, which is my negative terminal on my breadboard. So I'm going to click here, move it down to my negative terminal, and then I have my negative terminal being connected to my GND. And don't forget, it is color black. So I'm going to be changing it to color black, and then I have it well connected. Now, I will tell you the reason why we are not making these connections directly to the Arduino Uno board, but then we are making these ones directly to the Arduino Uno board. And then I would also show you the magics or the simple technology or the simple basic electronic principle behind this. So as we fed on, we are going to understand that. So then we now move to our second component, which is our RGB, what I call the 3-in-1 LED. So it has the red, it has the blue, it has the green. That is why we call it the RGB. R for red, blue for green, blue for B, and then G for green. So we have it then. So I'm going to be making my connections. Don't forget, we've already gotten our resistors being connected. So all I have to do is to look and track where each pin is going. So I have this resistor, which is the first resistor, going to pin number 12. I'm going to make sure I do the same thing here. So all I have to do is to probably come down here and then look through my connections and then make my first connection from my RGB, which is this, to my pin number 12. So I want to make it a little bit neat. So all I have to do is to negotiate a curve here, and then I can make another curve, and then I can put it to my pin number 12. I like to reduce this for simplicity. So don't forget, it is a color which is color green, and then I'm going to make sure I change it to color green. We want to do it color so that we can easily identify them by their colors. So I have my color green. I'm going to change it back to green. So I have my green here, well done. And then I continue to zoom in to look at my next cable. I have my cable blue. I'm going to make sure I make it to the pin number 11. So all I have to do is to still scroll down, come down a little bit, and then try to make it to pin number 11. So I first have to click this, try to negotiate a curve here, and then make another curve here to pin number 11. And don't forget, our cable is cable color blue. So I'm going to be changing it here to color blue, and then I have my blue well connected. Don't let the cables frighten you. It is very simple. Just follow each steps one after the other. So I'm going to make my connection here, and then probably if you can have a deep look. Anytime I try to hover my mouse around the what do you call it, my RGB, it tells me the color. So when I hover it, it tells me this is the green. I hover it, it tells me this is the blue, and then this is the cathode, which is the negative, and then this is the red. Now someone might ask, where is the positive of the RGB? The positives are just simple as they are the numbers that we keep connecting them to our Arduino Uno board. So right away, I'm going to make sure I make my negative connection, which is my negative terminal, to my negative lane here. Don't make this confuse you, so I'm going to make it here. And then change the color to color black, just to be able to identify that this is negative. Now, with my last connection on the RGB, I'm going to be making it to my pin number, which is my red here. I'm going to be making it to my pin number 10. So I'm going to make my connection right again to pin number 10, drag it, and then still want to negotiate a curve. Create another one here, and then click it to my pin number 10. Don't forget, this is color red. I'm going to change it to red, and then I have it nicely connected. Now we move to our third component, which is our buzzer. So I'm going to look at the buzzer. I have the buzzer here. It is very simple to connect. All I have to do is to look at the pins that the buzzer is being connected to. So I have the buzzer here, and then right away I have the positive terminal and then the negative terminal. So with the buzzer, all he has to do, with the buzzer, I have the positive and then the negative terminal. All I have to do is to make sure I connect each of them to the right port. So I have my positive terminal, which is my yellow one here, being connected to pin number 3, and I'm going to make sure I do it right in the right way. So first, all I have to do is to look out for my pin number 3 and then make my connection. So I'm going to come back to my circuit and then look out for my positive terminal, drag it, try to negotiate a curve here, do another curve, and then connect it to my pin number 3. So I call it a digital pin, which is the digital pins here. So I connect to the digital number 3. And then, if possibly, you should be able to know it is it is color yellow, and then I have to change it to yellow. So I have to still change it to yellow, and then I have my yellow wall connected. Now, my last one is my negative, which is my cathode terminal. So I'm going to look out for my negative and then look at where it has been connected. So I have it connected to the negative lane on my breadboard. So I'm going to make sure I do it in the correct way. So all I have to do is to still look at my negative terminal here, click on this, and then I'll connect it to my negative lane here. Then don't forget, we are representing all negative wires with black. So I'm going to change it to color black. Now I have my black well connected, and then I am going to move on to my fourth component, which is much easier to connect. My push button, which is this component I have here. So ladies and gentlemen, I believe you are having a nice time, and then you are able to follow. So feel free to release all your comments in the comment section. I am here to help you solve out any problems you are facing. Also, you can reach out to us on our WhatsApp channel. We have the link in the description below. Feel free to also subscribe to this YouTube channel, because from time to time we'll be bringing this with you, coming together to build more and more projects. Yes, so family, we still continue building our circuit. We have our components, fourth component being the push button. And then first is being connected, which is the negative terminal. I'm going to connect it. One thing about the push button is it does not really have a negative terminal. It does not really have a positive terminal. You have to create your own thing on your own. So you first have to, you can choose any of the terminals and then make it a negative one and then a positive one. So all I have to do is to connect my negative terminal right away to my negative lane on the breadboard. So I'm going to do the same thing here. So I have my negative. I'm going to make this my negative terminal. And then click on this, drag it into the negative lane. And then already it is black. And don't forget, we are representing all blacks for negatives. So this is already black. Now I'm also going to make sure that I make my positive terminal connection to the right pin. So as you can see, I have my positive terminal connection being here to the pin number 2. Now, with those who were saying, who had in mind this would have been much of a connection, now you can see it is being so simple to execute. So I'm going to look out for my negative terminal, my positive terminal, which is the green, and then it's being connected to pin number 2. So I'm going to make sure I do the same thing right away here. So all I have to do is to click on this, try to negotiate a curve here, and then negotiate another one, then connect it to my digital pin number 2. And don't forget, it is the color green. So I have to change it to my color green, and then I have everything well connected. So now I have my push button well connected, and now we are left with our last component being the servo motor, which is our simple security man here. So servo motor has 3 pins or 3 connections. If you are using the STEMAIDE coder kit, it's still the same thing, still the same steps. The servo motor has 3 connections, and then all it does is to positive, negative, and then the signal pin. So it has 3 pins, one being the positive pin, the negative pin, and then the signal pin. So whenever I try to hover my mouse around the pin, it can see. So first, I'm going to make my orange connection to my pin number 9. If you can track it well, you can have it seen to pin number 9. I'm going to make sure I connect it in the right way. So first, I'm going to make my connection here. Try to click here, and then I would want to negotiate a curve here. Then I can move on to keep on negotiating my curve. Another one to my pin number 9. So I have my pin number 9 here, and then all I do is to make the connections in the right way. And then all I can do is to change the color. Don't forget, we are using color orange. So I have my color, change it to orange, and then I make the same thing for my next color, which is color red, and then I make the same thing for brown. Now, the red is the positive terminal, and therefore is going on the positive lane on the breadboard, and then brown is the negative terminal, therefore it's going on the negative lane on the breadboard. So it's so simple. All I'm going to do is to make the same connections right away here. So I've got my positive, which is my power. Try to negotiate a curve somewhere here, and then put another one here, and then I can click it to my positive terminal. Probably I want to shift it a little bit so I can have some, probably want to give some space here for some reasons. So I also want to take this one back away to this side. Now, I'm going to be putting some connections here, and this is where I'm going to be telling you the reason why we are connecting everything to these lanes, whilst it is not the Arduino Uno board. Ladies and gentlemen, now we are left with our negative terminal of our servo motor. So I'm going to make sure I still do the same connection, and then try to negotiate a curve to the negative terminal. And don't forget, the negative terminal is brown, so I'm going to change it to dark brown. Then the positive, which is the color here, is it's a color red, so I'm going to make sure I put it to color red. So right away, we have our connection well made and everything connected to our Arduino Uno board. Now, with our last connections we are going to do is that we are going to be taking some power right away from the Arduino Uno board and then the negative from the Arduino Uno board onto our breadboard, so that all those that made their connections using this lane can also have power and then can function correctly. Now, this is the reason why we are connecting most of them to this lane, because the Arduino Uno board does not have enough ports for the power or all the circuit or all the components to input their power. And then the same thing for the ground. So all we have to do is to create more space here and then just link them up with this lane. Now, don't forget, the breadboard works in such a way that whenever we are connecting wires and then we are using the vertical lane, that means that power flows from here to this side. And then anytime we are using the horizontal lanes, which is here, which is what you can see over here, power flows from this side to the other side. So that's just a simple basics, fundamentals behind the breadboard. So now we've got our breadboard and everything well connected, our components being mounted, everything mounted. Now all we have to do is to connect our powers. So I'm going to take one power right away from the VCC, which is the V5. So one here. Then I'm going to be taking it from the V5, move it here, take another one, try to make sure it is on the positive lane on the breadboard, and then try to make it a little bit nice in such a way that it has not become a filthy work. So I'm going to be making this connection the right way, trying to zoom in a little bit. Then I'm trying to make sure I have the right connections at the right positions. Now, my last connection is the GND. I'm going to make sure I get it in the right connection, drag it, and then try to negotiate, find my ways to the negative terminal. And don't forget, I'm working on the negative terminal, so I have to change this color to color black, signifying the negative terminal. So probably it's not necessarily you have to change the color, but we want to be able to represent everything we are doing here with positive and then negatives. So make sure you're able to do it in the same way. So ladies and gentlemen, we have our circuit well built. I hope you enjoyed the process, and make sure you build it in such a way that you can easily play around it. So now I've got my circuit well built. All I have to do is to go in to the Google Drive, get the code, and then paste the code in my code section. Don't forget to look out for the Google Drive link in the description below, and then get all your code, and then make sure you're able to get everything, and then we can upload it on our Tinkercad software. So to stimulate this, all I have to do is to come to my code area right here. So I have my code area. I'm going to click on the code area. Now, this code is a little bit lengthy, and I'm going to take you through just a brief of it. So it uses functions, it uses logics a little bit. So this is a C++ code, and then we imported some libraries, and then we have some other connections well made to it. So I created variables here, and then I assigned the pin numbers. So this is the main reason why you can see me telling you to connect your pin number to pin number 7654 and whatever it is. So this is the main idea behind it. I created variables and then assigned these variables to specific pin numbers. For the trick pin, echo pin, servo motor, and then the push button, the buzzer, the RGB, and then any other thing you can imagine. Yes, and then I also had my parameters here. I also created variables and then assigned parameters to it. Since we are going to be measuring and then doing some little tricks of calculations, I created my variables and then I assigned some parameters in. Now, I also created, brought in some logics here to read the state of my push button and then my ultrasonic sensor. Then I finally wrote up my setup code, and then I wrote my logics, which is my if-else and then statement. So I wrote a Boolean expression, and then if the button is being pressed, which is true or false, these Boolean expressions are actually like true or false statements, whether this is correct or not. And then I also wrote my if-else statement. If this happens, then this should happen. Else, it shouldn't happen. Then I wrote my switches, I wrote my cases, and then my breaks, everything in here. I also wrote my delays, and then I finally wrote my open gate function. Just as you can see here, I have my open gate function. I also wrote my flash no car back function, and then everything. So this code is in the Google link or the Google Drive, and I would want you to head on to the description below, get your code, and then probably you can do your simple, basic connections. Now, ladies and gentlemen, we have our thing built, and then we would want to stimulate it. So first, with a Tinkercad, I am building 2 projects here, and therefore I have 2 Arduino Uno. Now, you are building 1 project, and therefore you have one, one board. So probably you should deal with 1 board. But then I'm going to click on the board I want to take my code from. So all I have to do is to come in and then click on the board, make sure I go to my code section, and then copy this code. First, I want to put my code to text. So I'm putting my code to text. So I'm dealing with this board, and then go to my code section, copy, and then all I have to do is to leave the section, go back again to the circuit we built, which is the circuit you have just built, and then click on this, and then move on to the code section. Click on the code section, highlight this, and then paste my code. And now I have my code. Now I'm going to be running this simple circuit, so all I have to do is to click on the Arduino Uno board I want to run, and then click on the stimulate button. Now I have everything well stimulated, and my ultrasonic sensor is sensing a distance. And just as you can see, I have taken my distance. It is red, signifying that there's nobody. And then anytime I press, it does not work. And then whenever I come back again to make my switches again, all it does is to go back again, and then that's my connections. Probably that is the circuit, and that is the code we built. Ladies and gentlemen, I believe you enjoyed this section, and don't forget to go in for your STEMAIDE Coder Kit, your all-in-one kit that can help you build this project physically with your hands, and then everything you got. Also, don't forget to join our WhatsApp channel, because the conversation over there is getting more enticing, and I want you to join our WhatsApp channel. Make sure you find your way and then navigate through this project. Ladies and gentlemen, this is where we will be drawing our curtains. This is where we will be bringing our section and our 3-day online workshop to an end. Don't forget to subscribe to this YouTube channel. Once again, I want to remind you, we have what we call the STEMAIDE Insight Series. This is a program we bring to you by STEMAIDE at the first Saturday of every month. So make sure you join our WhatsApp channel through the link in the description below, and then we can keep you updated as and when we are going to be hosting this kind of sessions again. Also, I'm recommending to you, if you are looking up to get your real-time classes, don't forget to head on to, or don't hesitate to head on to www.stemaide.com. We are running a vacation or a program called the STEMAIDE Next, and this is a 1-month full program that we would be building and then diving into just what we are doing here, basics behind technology. We'll be doing AI, we'll be doing coding in C++, we'll be doing self-discovery, we'll be doing future guidance. We'll also be doing much about prompt engineering and then virtual reality. So I would urge you to head on to www.stemaide.com, and then you can secure your slot. Don't forget, it is starting on coming Tuesday. So make sure you don't miss out this opportunity, And then don't also forget we are giving a discount, so make sure you're able to grab your discount. Ladies and gentlemen, families and friends, this is where we are saying goodbye to our section for today. And once again, thank you very much for being here with me. Don't forget to always make sure you are in our WhatsApp channel. And then don't also forget to make sure you subscribe to this YouTube channel. Thank you very much for today. Feel free to reach out to us. Once again, my name is Lapi Moriti Joseph. I'm a technology and a fintech educator specializing in robotics, STEM education, and financial technology. Thank you very much. See you some other time. Ladies and gentlemen, goodbye.